Hi friends, this is Sirisha, Assistant Professor in Mathematics, Department of SNH, Chabrol Engineering College. In this video lecture, we will discuss one of the most popular technique for solving the nonlinear equation. The method is called Newton-Raphson Method. Why I am saying this technique is quite popular? Because this method is easy to apply. Moreover, the converge is faster than earlier discussion techniques like bisection method, regular false method and fixed point iteration method. Newton-Raphson method is one of the most powerful method for finding root of a nonlinear equation. For finding root of a nonlinear equation. So let us consider an equation f of x is equal to 0 having graphical representation as how we are going to derive the Newton-Raphson formula used to find the root of the equation. Consider a curve. Consider a curve like this is y is equal to f of x. Just draw a tangent. Just draw a tangent to that curve. It touches the curve at some point. That point be xi comma f of xi. So xi is on x-axis and f of xi is on y coordinate. So we will derive Newton-Raphson formula using this tangent to that curve. Using this tangent to that curve y is equal to f of x. We know that the tangent is also as the slope of the curve. So slope it will be represented like f dash of x. So we will use equation of slope. We know the formula of slope, that is m is equal to change in y coordinate upon change in x coordinate. Change in y coordinate upon change in x coordinate, that is y minus y1 upon x minus x1. So here the point is x0 comma f of x0. We substitute the values y minus f of x0 by x minus x0. So the slope also can also be represented as f dash of x, that is equal to tan theta y minus f of x0 by x minus x0. So we rearranging this, we get x minus x0 is equal to y minus f of x0 by f dash of x0. So here the tangent line touches the intersects at x-axis, means y is equal to here y is equal to 0. Here y is equal to 0. We substitute y is equal to 0. We get the equation f dash of xi is equal to f of xi by xi minus xi plus 1. So hence xi plus 1 is equal to xi minus f of xi by f dash of xi. So in this way we will get iterations of the sequence of xi using this initial solution. So the generalization formula of Newton's-Raphson method is xi plus 1 is equal to xi minus f of xi by f dash of xi, where I is equal to 0, 1, 2 and so on. So as we can see, this is the formula for Newton-Raphson method. We can write Newton-Raphson method using Taylor series formula. We can write Newton-Raphson method using Taylor series formula. For this, Consider an equation f of x is equal to 0. Let x naught be an approximate of the root f of x is equal to 0. Let x naught be an approximate of the root for given equation f of x is equal to 0. Moreover, that x naught will belongs to closed interval a comma b. So let x naught plus h be the actual root. H is very small such that f of x naught plus h is equal to 0. So here this h value is x minus x naught is equal to h. From that x is equal to x naught plus h. So f of x naught plus h is equal to 0. If we write Taylor series for x naught around f naught, then we can write f of x is x naught plus h is equal to f of x naught plus h f dash of x naught plus h square by 2 factorial f double dash of x naught plus h cube by 3 factorial f triple dash of x naught plus and so on. So f of x naught plus h value can be written like x minus x naught into f dash of x naught plus x minus x naught whole square by 2 factorial into f double dash of x naught plus x minus x naught whole cube by 3 factorial into f triple dash of x naught. Here we neglect higher order terms. Why? Because h is a very small number, the powers of h is very small, so we neglect higher order terms. So now we can see left side of the equation f of x naught plus h means f of x, so that value is equal to 0. So from that we get 0 is equal to f of x naught plus h f dash of x naught. So f of x naught plus h f dash of x naught is equal to 0. So from this we get h is equal to minus f of x naught by f dash of x naught minus f of x naught by f dash of x naught. Hence the first approximation is x1 is equal to x naught plus h. So from that we can write x1 is equal to x naught. Now here we substitute h value, that is minus f of x naught by f dash of x naught. So the first approximation be x1 is equal to x naught minus f of x naught by f dash of x naught. So now the second approximation, x2 is equal to x1 minus f of x1 by f dash of x1. So on repeating this process we get xn plus 1 is equal to xn minus f of xn by f dash of xn. This is the required Newton-Raphson method formula. This is the required Newton-Raphson method formula. So the formula is xn plus 1 is equal to xn minus f of xn by f dash of xn. So next, steps to solve examples. So for given equation f of x is equal to 0, from that first we calculate the derivative of the given function, that is f dash of x, and choose an initial guess x naught as given below. Means let closed interval a comma b be any interval such that f of a less than 0 and f of b greater than 0, then x naught is equal to a plus b by 2. This is intermediate value property. From using intermediate value property we can derive interval of the given function. Then we find first iteration using the formula x1 is equal to x naught minus f of x naught by f dash of x naught. Similarly For second iteration, x2 is equal to x1 minus f of x1 by f dash of x1. So then by repetition of this process, we can find x3 value, x4 value and so on. So at last, we reach at a stage where we find xi plus 1 is equal to xi. Then we will stop the procedure. Hence, xi will be the required root of the given equation f of x is equal to 0. So this is graphical representation of steps to solve given function using Newton-Raphson method. So this is given curve y is equal to f of x. So we start with initial guess x1. Then we find the next iteration x2. x2 is the x-intercept of the tangent line to the graph of f at x1 comma f of x1. The approximation x3 is the x-intercept of the tangent line to the graph of f at x2 comma f of x2, and the approximation x4 is the x-intercept of the tangent line to the graph of f at x3 comma f of x3. So we continued in this way for finding the approximate or numerical solution, that is x star is convergent sequence is going to be converged. That x star will be the exact root. So this is the graphical representation of steps to solve given function using Newton-Raphson method. So after this, let us take few examples which will solve using this Newton-Raphson method. First problem, using Newton-Raphson method, find a real root of the equation x cube minus 3x minus 5 is equal to 0. So we have here given function is x cube minus 3x minus 5 is equal to 0. So let f of x is equal to x cube minus 3x minus 5 is equal to 0, and find the derivative of the given function f dash of x is equal to, so derivative of x cube is equal to 3x square and the derivative of x value is 1. So f dash of x is equal to 3x square minus 3, and we select the interval where the root of the given function lies. By putting x is equal to 0 in given function, we get f of 0 is equal to minus 5, and putting x is equal to 1, it gives f of 1 is equal to minus 7. At x is equal to 2, it gives f of 2 is equal to 2 cube minus 3 into 2 minus 5, that is equal to minus 3. And at x is equal to 3, f of 3 value is equal to 3 cube minus 3 into 3 minus 5, that value is equal to 13, greater than 0. Here at x is equal to 2, the value of f is minus 3, that is negative value. So at x is equal to 2, f of 2 is negative, and at x is equal to 3, f of 3 is positive. According to intermediate value property, there exists a root lies between 2 and 3. 2 and 3. So first we choose x naught is equal to 3. So our guess, first initial guess will be in between this interval 2 and 3. It will be 2 or either 3 or average of 2 and 3. Okay, so first we choose x naught is equal to 3. So now using the relation, the next iterations will be find using Newton-Raphson method. So the formula is xn plus 1 is equal to xn minus f of x by f dash of x. So put n is equal to 0. The equation will be x1 is equal to x naught minus f of x naught by f dash of x naught. So here x naught value is 3 minus f of x naught means 3 cube minus 3 into 3 minus 5 upon f dash of x value is 3x square minus 3. So we substitute here 3 into 3 square minus 3. So we simplifying this equation, we get x1 value is equal to 2.46. 2.46. So when n is equal to 1, then x2 is equal to x1 minus f of x1 by f dash of x1. So here x1 value is 2.46. We substitute this value in this relation. We get 2.46 minus f of x means x cube minus 3x minus 5. So 2.46 whole cube minus 3 into 2.46 minus 5 upon 3 into 2.46 whole square minus 3. We simplifying this, we get the value 2.295. So x2 value is 2.295. When n is equal to 2, then the relation x3 is equal to x2 minus f of x2 by f dash of x2. So here x2 value is 2.295 minus f of x2 means x cube minus 3 into x2 minus 5 by 3 into 2.295 whole square minus 3. So by simplifying this, we get the x3 value is 2.279. So when n is equal to 3, for next iteration, for take n is equal to 3, then x4 is equal to x3 minus f of x3 upon f dash of x3. So here x3 value is 2.279 minus 2.279 whole cube minus 3 into 2.279 minus 5 upon 3 into 2.79 whole square minus 3. So by simplifying this relation, we get x4 value is equal to 2.279. So here we observe that the values of x3 and the x4. So x3 value is 2.279 and also x4 value is also 2.279. So x3 and x4 are same. Hence the root of the given function is 2.279. 2.279. So coming to next problem. Compute the real root of x log x base 10 minus 1.2 is equal to 0 up to 4 decimal places using Newton-Raphson method. So here given function is x log x base 10 minus 1.2. And also it given carried out iterations up to 4 decimal places will be equal. 4 decimal places will be equal. So coming to solution, let given function be f of x is equal to x log x base 10 minus 1.2 and find by putting x is equal to 1 in given function, we get f of 1 is equal to 1 log 1 base 10 minus 1.2 is equal to minus 1.2. At x is equal to 2, f of 2 is equal to 2 log 2 base 10 minus 1.2 is equal to minus 0.5979. And at x is equal to 3, 3 log 3 base 10 minus 1.2 is equal to 0.2313. So here at x is equal to 2, f of 2 is negative, and at x is equal to 3, f of 3 is positive. So according to intermediate value property, the root lies between 2 and 3. So take the initial value x naught is equal to 3 and find f of x value at x naught. We get f of x naught is equal to 0.2313. Now we find derivative of the given function f dash of x. So f dash of x is equal to 1 log x base 10 plus x into 1 by x log 10 base e, log e base 10. So next we find f dash of x value at initial guess, that is f dash of 3 is equal to log 3 base 10 plus 1 log 0.4342 is equal to 0.9113. So the value of f dash of 3 is equal to 0.9113. So we get f dash of x naught value at x naught is equal to 3 is 0.9113. So the next iterations will be find using Newton-Raphson method. The initial guess x naught is equal to 3. So when n is equal to 0, we get x1 is equal to x naught minus f of x naught by f dash of x naught. We substitute x naught value, f of x naught value and f dash of x naught value in this relation. We get 3 minus 0.2313 upon 0.9113 is equal to 2.7462. So for next iteration, will be find using Newton-Raphson method. So f of x1 is equal to, so here x1 value is 2.7462. 2.7462. So now substitute x1 value in given function. We get f of x1 is equal to 2.7462 into log 2.7462 base 10 minus 1.20 is equal to, so this value is 1.2048 minus 1.20, we get the value 0.0048. So f of x1 is equal to 0.0048. And also we find f dash of x1, that is log 2.7462 base 10 plus log e base 10 is equal to 0.4387 plus 0.4342, that is equal to 0.8729. So the second approximation, when n is equal to 1, the second approximation is x2 is equal to x1 minus f of x1 by f dash of x1. So we substitute the values x1, f of x1 and f dash of x1. we get x2 value is equal to 2.7407. So we repeat this process at x2 and x3 values are same. So 2.7407 is the real root of the given equation corrected up to 4 decimal places. So we look at one more problem. Using Newton-Raphson method, compute the real root of the following equation corrected to 4 decimal places. So x is equal to square root of 28. So x is equal to square root 28. So here given function is x is equal to square root 28. Solution: given x is equal to square root 28, this can be written as x square is equal to 28, that is x square minus 28 is equal to 0, that is equal to f of x. So that the derivative of this function becomes f dash of x is equal to 2x. F dash of x is equal to 2x. So here we start with the value at x is equal to 5. At x is equal to 5, the value of f of 5 is equal to 25 minus 28, that is equal to minus 3. And at x is equal to 6, the value of f of 6 is equal to 36 minus 28, that is equal to 8. As value of f of x at x is equal to 5 is negative and at x is equal to 6 is positive. So according to intermediate value property, the root lies between 5 and 6. So and near to 5. So the root lies between 5 and 6. Let us take initial value x naught is equal to 5. So f of x naught is equal to, so here f of x value at 5 is minus 3, and also we find f dash of x value at 5, we get f dash of x naught is equal to 10. For next iterations, using Newton-Raphson formula, when n is equal to 0, x1 is equal to x naught minus f of x naught by f dash of x naught. We substitute x naught value, f of x naught value and f dash of x naught value in this relation. We get 5 minus 3 upon 10, that is equal to 5 plus 0.3, that is equal to 5.3. So now we find the values of f of x and f dash of x1 for second iteration. So f of 5.3 is equal to 5.3 whole square minus 28. So we will get 0.09. And f dash of 5.3 is equal to 2 into 5.3, that is equal to 10.60. So when n is equal to 1, the second iteration, when n is equal to 1, x2 is equal to x1 minus f of x1 by f dash of x1. So we substitute these values. So x1 is 5.3 minus f of x1 value is 0.09 upon 10.60, that is equal to 5.2915. So here also we find values of f of x2 and f dash of x2 for third iteration. So at x2 value, f of x2 is equal to 5.2915 whole square minus 28, that is equal to 0.00027 minus 0.000027, and f dash of x naught is equal to 2 into 5.2915, that is equal to 10.583. So, and when n is equal to 2, x3 is equal to x2 minus f of x2 by f dash of x2, that is equal to 5.291502. So, which is correct up to 4 decimals. We get required root of given function, that is x is equal to 5.2915. So, coming to applications of Newton-Raphson method. So, using this Newton-Raphson method to find square root of any number, to find the inverse, and using this method to find inverse square root, using this method we find root of any non-linear equation. So, limitations of Newton-Raphson method. When this method fails, the derivative of the given function is equal to 0. So, the main disaster is f dash of x is equal to 0 is real disaster for this method, and f double dash of x is equal to 0 causes the diverge of the solution. Sometimes get trapped in local maxima and minimum values. So, this is about Newton-Raphson method. I hope you understand this Newton-Raphson method. It is very powerful method for finding root of a nonlinear equation. Thank you.